So let's look at how to solve a rational equation in inequality graphically. So here we have a function f of x, and that is represented by that graph. And we want to know, when is f of x exactly equal to 0? Well, those are the x-intercepts, and in this case there's one x-intercept. So we'd look to see what the x value is there, and it is -2. Okay, and the next question is, when is f of x less than 0? And that would be, when does the graph dip down below the x-axis? And that happens in this section of the graph. And so then we look at what the, let's see, what the x values are for that section of graph. And we knew that this point right here was negative, that's -2, the x-intercept itself. That's -2. Okay, and so it would be all of the x's that go between -2 and then the asymptote. And the asymptote is there at x equals 0. Okay, so it would be from -2 to 0, but we can't actually go and touch that asymptote, so we have a parentheses around the 0. X is just everything below 0 until we get to -2, but again we don't include it, so we use parentheses, because when it equals -2, then that's when our f of x is equal to 0. Okay, so the question is asking in terms of the graph, when is it above or below the x-axis, and the answer is in terms of the x values that correspond to that section of the graph. Okay, so in the next one we're looking at, when is f of x above, and that happens twice here in this section as well as that section. So we just need to have our interval notation for both of those parts in the graph. So from -infinity, so let's see, -infinity to -2, or the other part where we go from that asymptote, the vertical asymptote, and then head off towards infinity.